Hello, everyone, and Happy New Year. My name is Michel, and I would like to thank you very much for joining us today to listen to Dr. Simon Stott, who will be talking to us about his main Parkinson's research takeaways from 2022, as well as the research results from 2023 that he will be looking for. Simon is the Director of Research at Cure Parkinsons and has more than 20 years of experience in the field of Parkinson's research, so we're very fortunate to have him. He also maintains the Science of Parkinson's website. If you're not familiar with this website, this is an amazing source of information. It is basically giving you Parkinson's key information in plain English, easy to understand, and at the same time, heavily scientific. It's a key source of information for Mark and I. So please do visit the website, Science of Parkinson's, and subscribe. It's for free. I would like to remind everyone that this session is for information and education purposes only. So if you are seeking medical advice, diagnosis, or treatment, you should consult a medical professional as always. Now, an important feature of those sessions is that there will be time for Q&A at the end of the presentation. So please use the Q&A function at the bottom of your screen to put your questions online as they come to your mind as we listen to Simon. And I would like to say that for those of you who don't know us yet, No Silver Bullet is a Parkinson's support group managed by Mark Lambert and myself. You can see Mark on the video as a panelist with me and Simon. What we really want to do is to help you to become well-informed journalist in your condition, to know everything about it as a journalist. And a session like tonight is exactly going into that direction. We also want you to make informed choices on how to adapt your lifestyle to slow down disease progression. So we are therefore organizing Zoom sessions with researchers and PD specialists to update you on the latest advances in science and medicine, but also nutrition, exercise, and wellness. You will remember Baz Bloom a few weeks ago talking to us about exercise. Our next session will be about nutrition with Dr. Philip Matthews from New Zealand, which a person that a lot of you already know. We post the recordings of our sessions on our YouTube channel as well as on Spotify, and I invite you to subscribe to those channels so that you are informed when we post new content. That's the best way to keep in touch with us. The details for those channels are in the chat section at the bottom of your screen. But let's come back to today's topic and to Simon, who will be talking to us about his main research takeaways of 2022, as well as the research results he will be looking for in 2023. Simon, the stage is yours.
Thank you very much, Michelle, and hello and good evening, good morning, wherever you may be, folks. I'm just going to share my screen, or I'm going to try to if technology lets me.
You should be able to do that.
Yep. Oops. Word should is the key word there. I should be able to do it, and I hopefully have.
Yes.
Let's go full screen. So yeah, my name is Simon and I'm the Director of Research at Cure Parkinsons. We're a research charity that's registered in the UK, but we fund research worldwide that is focused on disease-modifying therapies for Parkinson's. And just for full disclosure, some of the clinical trials and some of the research that we'll be discussing tonight or today has been supported by Cure Parkinson's, and where that is applicable, I've kind of thrown in our label. So this is a good slide to start off with. I find it gives you it puts everything into context. This is a measure of time and the amount of research that's been done over that time. And if you look on the left-hand side, down the bottom, you can see 1817, which is when James Parkinson first described the condition. And we go across all the way to 2022. The bars in blue represent the number of research papers that are published each year that have the keyword Parkinson's in them. And up until the 31st of December 2022, there had been 161,334. And 80% of that, or 80% of everything that's been published on Parkinson's has been published since the year 2000. But remarkably, and this is what really blows my mind, is that there were over 11,000 research reports last year on Parkinson's. And while I haven't read all of those papers, I have flicked through one or two. And what I'd like to do today is provide you with some insights from 2020, some of the bits of research that I thought were really quite interesting, And also, I'm going to point out a few things to look out for in 2023. So firstly, with 2022, we had a really interesting year in terms of clinical trial results. And we were inundated with clinical trial results, and some of them were really, really interesting. And towards the top of that really, really interesting list, there was one trial called the CARMET study, which was conducted by a biotech company called Entrin. And now Entrin's been developing a small molecule, a synthetic version of a protein called squalene. Squalene is a molecule that was discovered in the spiny dogfish, which is a type of shark you can see along the bottom here. And these sharks never get sick, basically. They don't get cancer, and they've got a very, very robust immune system. But what the researchers found was that this protein also has a very potent aggregating effect on a protein called alpha-synuclein. And if you're familiar with the biology of Parkinson's disease, you'll have heard this term alpha-synuclein quite a lot. It sounds like a distant galaxy, but it's one of the most common proteins in your brain. And in people with Parkinson's, for some reason, it seems to aggregate inside neurons and cause trouble, we think. And this molecule called squalene stops it from aggregating. So this biotech company has been developing a synthetic version of squalene, which they called ENT01. And in 2019, they published the results of their phase 1 clinical trial, which was called the RASMIT study. And they looked at this molecule in 44 people with Parkinson's and constipation. And they found that it had very low bioavailability. Their molecule was basically not getting into the blood. It wasn't getting into the body. It was going into the gut and staying in the gut and just passing through the body, passing through the digestive system. But it did have a positive effect in terms of constipation. It helped folks with constipation. Instead of having just one bowel movement a week, they were getting up to about 3 or 4. So this was a very positive effect, and they thought, let's continue developing this agent. And so based on these phase 1 results, they set up a phase 2 randomized clinical trial of ENT01, and they enrolled 150 individuals with Parkinson's and constipation. And this was the CARMET study, and they treated these individuals and monitored them for 25 days. Now they saw a significant improvement in constipation. And what's really interesting in these results is that the benefit was maintained after the treatment was stopped. If you look at this graph here, you can see in the blue line across the bottom, these are the placebo-treated individuals, and they didn't improve across the 25 days of treatment, the 2 weeks. 2 weeks, there was 25 days of treatment, and then 2 weeks afterwards, you can see after they've stopped treatment, there's still no improvement, and 6 weeks after they've stopped treatment, there's still no improvement. But in the people that were treated with ENT01, which is the black line, you can see that they quickly go from less than 1 bowel movement a week up to about 3. And then after they've stopped, 2 weeks after they've stopped treatment, they're still up around 2, and they're still up around 2 bowel movements a week at 6 weeks post-treatment. So this was quite encouraging. This was really interesting. But then they started digging into the data. And when they started digging into the data, they found something really remarkable. At the start of the study, there were 13 individuals who were having hallucinations. They were experiencing hallucinations. Hallucinations can be a common side effect with Parkinson's. And there were 6 people in the ENT01 treated group, and there were 7 of these 13 people in the placebo group. Now, if you look at the placebo group on the right-hand side here, the graph on the right-hand side, you will see that the red bar across the bottom, or across the middle, is the average. And you can see that it stays basically the same across the treatment period and all the way out past 6 weeks post-treatment. But then if you shift to the graph on the left-hand side, this is the ENT01 group. And if you look at the red bars, which is the average, it immediately starts dropping, and it stays down even after treatment. So 6 weeks after treatment, these individuals have still got very low levels of hallucination. And this is quite remarkable. This really sort of left me scratching my head, because this is a molecule that that does not enter the body. It just has its activity in the gut. It doesn't get into the blood. And so how on earth does it get to the brain? Now, there's been a lot of research. I don't have an answer for you, but the biotech company is certainly investigating this, and they're quite excited about this finding. But there's been a lot of interest recently about the gut in Parkinson's research and the connection with the brain. And this is an area that I will certainly be keeping a very close eye on, because I found this result really, really interesting. Another biotech company, or another clinical trial that had an interesting result, was conducted by a biotech company called Anavex. And they have an agent called Blackanosine. Blackanosine is a sigma-1, it targets a protein called sigma-1, which is a chaperone protein. And a chaperone protein is a protein that helps to fold other proteins. When a protein is made, it has to be folded into a particular way for it to have its effect and to do its function. And chaperone proteins are the proteins that help to fold proteins into their correct formation. And sigma-1 is important, particularly important when cells get stressed. They help to help the stressed cell become less stressed, basically, which could be really useful in situations where neuroprotection is required. So Blackanosine is a drug that increases the activity of this sigma-1 protein. And Anavex Life Sciences, the biotech company, in March of 2022, presented the results of their phase 2 double-blind clinical trial, where they had treated people for 14 weeks. They treated 132 people, to be exact, with who all of these individuals had Parkinson's, and they also had evidence of Parkinson's dementia. So there was a cognitive deficit in the study as well. And they tested 2 doses of their drug, and they compared this with a placebo treatment for the 14-week period. And what they found was a 14-point improvement in the UPDRS total score. Now, the UPDRS is the clinical measure that we use for assessing people with Parkinson's. In total, you can have a total score of 200. So it's 0 to 200. And in the study, they saw an improvement of 14.5 points. Now, this has to be taken into consideration that the people in this trial were also on normal L-DOPA medication. So this is a massive effect. This is really quite jaw-dropping. Excuse me, it's late in the day here and a bit fatigued after a busy day. And this effect was seen across all of the various components of the UPDRS, part 1, part 2, part 3, part 4, part 5. So this is another really interesting effect. And they looked at blood, and they saw that sigma-1 levels were elevated in the blood of people treated with this agent as well. Now, by itself, this is interesting, but then they also in December published, well, not published, but announced the results of their phase 2/3 trial in Alzheimer's as well. And this study involved 509 people with early Alzheimer's, and they had been treated for 48 weeks with the drug, and they showed statistically significant reductions in their cognitive decline, and also statistically and clinically meaningful response with regards to their quality of life and function. So this is another set of clinical trial results that I thought were quite interesting from 2022. And it'll be interesting to see what the biotech company does next with this agent. Then we also had the Nadepark clinical trial results. And this is a study that's being conducted up in Norway. And they're looking at an agent called nicotinamide riboside, which is a form of vitamin B3. And this plays an important role in the energy production in cells, as well as other functions. But the researchers in Norway were interested in what this could possibly do for people with Parkinson's. And so they conducted a small phase 1 clinical trial by supplementing people with Parkinson's with nicotinamide riboside. And they recruited 30 people, and they put half of them on a placebo treatment and the other half on nicotinamide riboside. And they found that, firstly, that the treatment was very safe and well tolerated, but importantly, that they saw significant improvements and increased levels of mitochondrial function and waste disposal, cellular waste disposal. So mitochondria are the power stations of cells. They provide the cell with all of the energy that it requires. And in Parkinson's, there is typically a mitochondrial there's a reduction in mitochondrial activity with a lot of people with Parkinson's. And so improving mitochondrial function is pretty key, pretty important. And improving cellular waste disposal is also improvement. We were talking about that protein alpha-synuclein before, which seems to aggregate and clump up in cells. If you can boost cellular waste disposal, then you can hopefully clear a lot of that alpha-synuclein protein away. So they saw that they were encouraged by this phase 1 study, and they now have a phase 2 study, a large phase 2 study where they've recruited 400 people with Parkinson's, and they're going to be treating them and following them over the course of a year. And that study is called the Nadepark study, and we should hopefully have the results of the Nadepark study in late 2024, maybe early 2025. But those were 3 clinical trials that I thought were really interesting. Other insights came just with regards to the biology or some of the potential biology underlying Parkinson's. Firstly, this protein I was talking about before, alpha-synuclein, and how it aggregates and clumps up in people with Parkinson's. A lot of researchers have focused their attention on alpha-synuclein for the last 2 decades, and it's becoming more and more apparent that alpha-synuclein appears to play a role with regards to the immune response of neurons. 2 papers, which are highlighted here, demonstrated that alpha-synuclein is required for a normal inflammatory response of neurons. So perhaps the buildup of protein in neurons in people with Parkinson's could be too much of a buildup, and it results in too much of an inflammatory immune response. An inflammatory response. It's a different angle on alpha-synuclein, and it's an interesting angle. It'll be curious. I'll be very, very curious to see what data or what research comes from these findings. Another interesting bit of biology was related to a different protein associated with Parkinson's, one called GCase. People with a genetic mutation in their GBA gene have reduced levels of this protein called GCase. And GCase is involved with waste disposal in cells. And what we find in people with Parkinson's is they have reduced levels of GCase. But we've never really understood why they have reduced levels of GCase, because they typically produce a GCase protein, but it's been misfolded. It's not quite in its correct formation. And what researchers in New York found last year, when they looked really, really closely at this protein, is that it's not getting to the location where it's supposed to be getting to do its function. Instead, that location is called the lysosome, and lysosomes are like the rubbish bags of cells. That's where all the rubbish gets dumped, and this GCase protein is one of many enzymes that help to break down that rubbish and dispose of it. But what happens is the GCase actually starts piling up on the outside of the lysosome, and it actually prevents other enzymes from getting into the lysosome. And so you have a bit of a traffic jam as a result. So that's a really interesting bit of biology. that came out of 2022 as well. Thirdly, there was a set of interesting results in terms of sugar. And this one has immediate applications for people with Parkinson's, I think. What they found was that people with Parkinson's typically have a higher intake of carbohydrates, but those carbohydrates are primarily due to significantly higher levels of sugar intake. And the sugar intake, consuming more total sugar, was associated with experiencing chronic pain, cognitive decline, depression, and reporting of impulse control problems. It was also, it was also associated with increase in other non-motor symptoms, such as worsening constipation, and also greater daily L-DOPA requirements. So one possible takeaway here is to limit the level of sugar we are taking in. And that probably applies to me, having just had a chocolate cookie, so I probably should eat my own words. And finally, thirdly, one major takeaway from 2022 was new projects and new resources that have been made available. And one of the exciting projects is the EJS ACT-PD clinical trial platform that's being developed here in the UK. This is a multi-arm, multi-stage clinical trial platform design. And by multi-arm, multi-stage, we mean that there'll be one placebo and it'll be compared with multiple treatments all at the same time. And what researchers will hopefully be able to do is rapidly change or rapidly stop treatments that are showing no signs of benefit, stopping that particular arm, that particular treatment, and introducing a new treatment. So over time, in this schematic, for example, you see that treatment 1 is continuing across time up for 5 years, whereas treatment 2 and 3 have been stopped after year 1 because they didn't show any benefit. And treatment 4 and 5 have been introduced. And then treatments 6 and 7 have also been introduced in later years. And this is a method of actually speeding up clinical testing of new treatments for Parkinson's. So it's a very, very exciting development. It's going to be a massive project. There's going to be 400 people per arm in each of these arms. And it's going to require a lot of effort and resources from the local Parkinson's community. But it's certainly a project that is worth the effort if it can speed up the introduction of new treatments for people, for the community itself. It's been tried and tested in prostate cancer, and it's improved standard of care significantly. It's currently being used also in multiple sclerosis here in the UK, and in the US, I believe ALS has also got a MAMS platform up and running. So it's now time for Parkinson's to have its MAMS, and I'm really, really excited about this new resource. Another new tool, a new project here in the UK. Again, apologies for those outside the UK, but the UK Parkinson's Disease Clinical Studies Group. This has been initiated by Professor Oliver Bandman at Sheffield University. And the aim of the PDCSG is to ensure that we have improved patient access to clinical trials, as well as helping to develop and support clinical trials across the UK. So there'll be also training programs for young clinical researchers who are keen to play a role in the future development of Parkinson's research. And if you're interested, I've got the website down the bottom there. If you're taking notes, please stop. What you can do is you can email me and I can send you these slides. I'm happy to share the slides. There's nothing confidential in any of this, and there'll be a few more links provided here. So just send me an email. My email will be at the end of the presentation. So looking to 2023, what are we going to be looking out for? Firstly, a lot of clinical trial results. Despite COVID's setting things back, it didn't really slow down the progress of clinical trials for Parkinson's. And one of the really exciting classes of drugs with regards to Parkinson's research is GLP-1 receptor agonists. These drugs are used in diabetes to help modulate levels of insulin in the blood. But in the early 2000s, researchers found that they also have neuroprotective effects in models of Parkinson's, and that resulted in a set of clinical trials. So in 2017, the results of the exenatide phase 2 trial was published, and across a 42-week period, the researchers found that there was a stabilization of the motor features of Parkinson's in the exenatide-treated group, while the placebo-treated group progressively got worse. And this has resulted in a group of GLP-1 agonists going into clinical trial for Parkinson's. In 2022, we learned the results of the liraglutide study. This is a GLP-1 agonist very similar to Parkinson's, to exenatide. And in that study, they saw significant improvements in non-motor symptoms. So this is adding to the body of research that's suggesting that this class of drug could be useful for people with Parkinson's. But in 2023, we're going to be learning the results of the lixazenatide study and the Neurally study and the Peptron study. Now, what's interesting here is that after the exenatide results were published from the phase 2 study, Neurally and Peptron immediately developed their own new version of GLP-1 agonist receptor agonists. And these drugs actually penetrate the brain better than exenatide itself. So it'll be interesting to see their results. Peptron has already announced the top line results of their study. This was just over the Christmas break. They announced that they didn't see a positive effect on their primary outcome, but the company isn't going to stop their clinical trials of their drug. They want to continue because they saw encouraging results in other measures that they thought were interesting enough that they would keep going with their clinical trial program. So it'll be interesting to see in 2023 what data they actually had, and what it was about the data that kept them interested and kept them going. And then there'll be new clinical trials also being initiated in 2023. And that brings me to today's big news. Here in the office where I am in London tonight, all day long, the employees of Cure Parkinsons have been walking around saying happy Ambroxol Day to each other. Ambroxol is a respiratory medication that is being repurposed for Parkinson's because it's been shown that this agent can elevate or increase levels of the GCase enzyme that we were talking about back a few slides back. This is the enzyme that's involved with waste disposal, and levels of GCase are reduced in people with Parkinson's. So today we announced that we were initiating the phase 3 clinical trial for Ambroxol, phase 3 being the final stage in the clinical development of agents before you go to the regulator and you ask whether you've done enough research for the drug to be approved for a medical condition. And this trial is being funded by Cure Parkinson's, the Van Andel Institute, Parkinson's UK, and the John Black Foundation. And it's based on a lot of preclinical research that's showing that Ambroxol can rescue models of Parkinson's, both cellular models, also mouse models, and primate models. And all of that preclinical research led to a phase 2 trial that was funded by Cure Parkinson's, the Van Andel Institute, and the John Black Foundation. And that trial, phase 2 trial, the results of that were published in 2020, and that was called the AIM-PD study, Ambroxol and disease modification for Parkinson's. And that study was very small. It only involved 18 participants, and all of them were treated with Ambroxol for 6 months. It was basically to test whether the drug was safe with that long-term treatment, and it was a higher dose than is typically used for Ambroxol as a respiratory medication. But importantly, the results showed that firstly, it's safe and well tolerated, and at elevated levels of this enzyme called GCase, both in the blood and in the brain. So that was a very encouraging result, and that led to the initiation of what's called the ASPRO-PD, or excuse me, Ambroxol to slow the progression of Parkinson's disease. And this is a nationwide UK-based study being led by Professor Anthony Shapiro at UCL here in London. And this is to determine whether Ambroxol can actually slow the progression of Parkinson's. There were some clinical measures taken in the phase 2 study, but the study was too small to actually say yes or no it was having an effect. So this is a very big study. It's going to be 2 years of treatment and 330 people, half of whom are going to have a GBA genetic variation, and the other half are going to just be idiopathic Parkinson's. So this is Parkinson's with no genetic mutation associated with it. And the primary outcome of that study will be the clinician-rated the clinical rating scale, the MDS-UPDRS. Now, if you're interested in more information about this study, there's a link on the bottom of the slide here. And you can also have a look at the PD Frontline study. This is a resource for the Parkinson's community where you can find out, firstly, if you are carrying a GBA gene, GBA mutation, excuse me. It's a very simple process. You spit into a jar, you send it away, and they send you back the results. But if you're interested in participating in the Ambroxol phase 3 study, this is probably a good place to start. And again, don't worry about writing down the links. You can email me and I'm happy to share the slides. Another interesting clinical trial that'll be kicking off this year is the STEM-PD study. Now, a lot of people in the Parkinson's community are very interested in stem cells for the treatment of Parkinson's, given that dopamine neurons are lost in the condition. One solution to that problem is to actually start replacing them. And what researchers have done is they've spent the last few years developing recipes for making dopamine neurons in cell culture from stem cells. And there are now a couple of clinical trials focused on stem cell transplantation for Parkinson's. And the STEM-PD study will be starting this year. It's a collaboration between Lund University in Sweden, Novo Nordisk, the large pharmaceutical company, and the University of Cambridge. And they'll be recruiting 8 people. It's a small study. They're just going to be checking whether the procedure is safe and well tolerated. And 8 people will be transplanted and followed for the next 3 years. Firstly, just 1 year will be focused on the actual safety of the procedure, and then the following 2 years will be looking at whether the transplantation is actually having an effect. So that is one clinical trial we'll be looking out for this year. For those people who aren't interested in cough syrup or stem cells, but more interested in exercise, there's a massive clinical trial being undertaken in the US, and it's called the SPARK study. This is going to be a multi-site study, so it's all the way across the US, and it's going to look at endurance treadmill exercise in 370 people to determine whether high intensity endurance exercise is efficacious in Parkinson's. So that could be something for folks who are less interested in drug trials and more interested in exercise. And the third thing I'll be looking out for in 2023 is the WPC meeting. This is going to be held in Barcelona. And if you have the opportunity to get to Barcelona during July the 4th to the 7th, it is a really remarkable meeting. I've been to quite a few conferences in my life, scientific conferences, and typically they involve a lot of scientists getting together and talking data. And the WPC, World Parkinson's Congress, is unique among these conferences in that probably half of the people there, if not more, maybe 2/3 of the people there, are the Parkinson's patient community, people with Parkinson's. And it's a wonderful opportunity for researchers and Parkinson's, the Parkinson's community alike to get together, to interact, and to collaborate. It's wonderful. It's wonderful the way a lot of the research that's currently being undertaken has come from conversations, simple conversations that have been had at the WPC meeting. And if nothing else, Barcelona is going to be a fantastic location for this meeting. So if you have the opportunity, I would highly, highly, highly recommend going to the WPC meeting. It's not all about science as well. If you're interested in diet or exercise related to Parkinson's, if you're interested in anything related to improving lifestyle in Parkinson's, the WPC meeting is definitely going to have something for everyone. So just summarizing the insights from 2022, there was a lot of encouraging clinical trial results, really interesting data coming through, and some very interesting insights in the potential biology underlying the condition, and a lot of new resources that can help to drive Parkinson's research forward. And looking out to 2023, there's going to be a lot more clinical trial results coming, and there will be the initiation of a lot of new trials as well. Yay, and Broxol phase 3 is finally underway. And then, of course, there'll be the World Parkinson's meeting as well. And as I said, I'll be happy to take any questions. And if you would like a copy of my slides, by all means, just email me at simon@cureparkinsons.org.uk. And with that, I'll be happy to take any questions.
Thank you very much, Simon. And actually, if you allow us, we will probably attach your presentation to the YouTube posting of the video recording of this session so that everyone can access it.
Yep.
On the top, I just wanted to pick up on a few things you said, that people who are interested in exercise and how much exercise they should be doing should be looking at the video recording of or interview of Professor Bas Bloem a couple of months ago. He's definitely one of the worldwide celebrities in this area, and a sommelier in terms of like knowledge of Parkinson's. Simon, you touched also on the topic of nutrition that would be debated at the WPC. So I'm delighted to be able to confirm that actually we will have Matthew Phillips from New Zealand talking to us about keto diet and fasting in a few weeks. I think it's on the 6th of February to be confirmed.
Go
and
Kiwis.
Laurie Mishley, yeah, go Kiwis, exactly. And Laurie Mishley, with your help, Simon, has accepted to speak to us in May. So we will have a lot of opportunities to listen about advice on nutrition in the coming months.
Wonderful.
One question I had for you before we look at what our audience has in store in the Q&A box. You published an article recently, Simon, about the fact that there is probably more than one type of Parkinson's. We have also heard from people like Alberto Espe that as long as we basically consider the patient to be a one-type entity and don't look into more detail at the bioassay of the different type of patients that are carrying Parkinson's, we will struggle with our clinical trials. What is your opinion on this? Do you see a trend to be more scientific, so to speak, about not only the product that we want to trial on, but actually also determining the different types of patients that could be targeted by those solutions?
Yeah, no, definitely. We have a tendency as human beings to group things. It makes thinking easier to group objects and group peoples, and it's innate in us. So there's almost like a tribalism. But with regards to clinical trials in Parkinson's, we've always kind of taken a treatment and taken a group of people with Parkinson's and tried a treatment on them. And to date, the vast majority have failed in terms of slowing the progression of the condition. But what researchers are doing now is they're going back and actually looking at the data in a lot of these big clinical trials, and they're asking who responded, who actually did have a good response in that group that we treated, and what's different about those 1 or 2 or 5 or 6, however many individuals from the rest. Rather than simply saying we didn't see any effect in this large group, so that treatment's obviously rubbish, they're saying which of the people in this group did respond, and maybe that treatment is a good treatment for those individuals. That's one way of approaching this, one way of approaching Parkinson's, to try and determine what sort of different groups there are in the population that's affected by the condition. Another way is to look at biomarkers, which is what Professor Espay is kind of trying to do with his project in Cincinnati. And other groups are trying this as well in terms of genetics and other approaches. The PPMI study, the Michael J. Fox Foundation PPMI study, is a good example there as well. So we're coming at the problem from different angles, and hopefully we'll meet somewhere in the middle with some solutions. I'm not sure that we'll need to necessarily get it right down to the individual, but it might be that with Parkinson's, we have a condition that looks very similar in its output, its physical output, but biologically there could be multiple pathways to getting to that output, and that will require different treatments. I hope that makes sense. Very much.
No, it's encouraging to see that there is an awareness of this that is developing in the scientific community.
Yeah.
I'm looking at the questions on the Q&A page, and I see here someone was asking about sleep. Now, this is not a topic we touched on, and I can't remember having seen it in the Science of Parkinson's, but I haven't been following it for so many years. Someone is asking, is there such a thing as too much sleep, basically as a cause of Parkinson's? Do you have a view on this? I know it's a bit out of the field, but
no. There's a really interesting body of research around this. So people with Parkinson's have disrupted sleep, and it is a problem. It's problematic because they're exhausted, they're fatigued. That makes them more anxious, and sleep quality is really, really important for everybody, not just people with Parkinson's. But there are researchers who have been looking at slow wave sleep, for example, and in ways of increasing slow wave sleep, because like slow wave sleep is sort of a deep level of sleep, and this is what's lost with people with Parkinson's. And it's a period in sleep when the brain is actually able to go about the process of cleaning itself, getting rid of a lot of the waste. There's a set of tubes in our brain called the lymphatic system, and in slow wave sleep we're cleaning away a lot of the rubbish through the lymphatic system. And what these researchers have been doing in mice is disrupting the lymphatic system, and they find that in Parkinson's models they get a buildup of alpha-synuclein protein and these other proteins, and so they're looking at various treatments that can help to enhance the lymphatic system and improve slow wave sleep. And what they find is these treatments help to reduce the levels of alpha-synuclein and other waste in the brain. So yeah, sleep is really, really important, and I don't think there is such a thing as having too much sleep, but it's the quality of the sleep that really matters.
Yes. Well, sleep is definitely a topic we would like to cover in the future. We haven't yet found the perfect specialist to talk about it, but actually, if you do have suggestions, we can talk about it offline.
Well, I'll email you.
Thank you very much. A question from Mark, who is asking about the Ambroxol phase 3 study, and he's asking whether there is a timing for the interim results of that study.
Sorry, for the Ambroxol study, the results?
Yes. Is there like a timing for interim results of the trial?
There won't be interim results. It'll be 2 years of treatment and the 330 people involved.
Okay. So it will be at the end of the 2-year period.
Yes.
Okay. Question from Bob, who is basically congratulating you for a great talk, and I agree with that. He's asking, can you comment on the progress of gene therapy for Parkinson's?
Gene therapy for Parkinson's is a pretty broad topic. For those who aren't familiar, gene therapy is a treatment where it doesn't involve a pill, but rather the introduction of DNA. And what we what researchers do is they take a virus, and they take out all the disease-causing stuff from the virus, and make it harmless. But what's left is a very good biological delivery system, and then you can stick whatever DNA you want in that biological delivery system and inject it in the body, and the DNA can be inserted into cells, and it starts to produce whatever you want to produce. And researchers have used this gene therapy approach to make cells produce dopamine, for example, and dopamine being a chemical that's reduced in people with Parkinson's brains. And they've done this with great success in clinical trials. It's still experimental, I should add, but they haven't just stopped with dopamine. They've also looked at proteins like GDNF, and glial cell line derived neurotrophic factor is a molecule that's very neuroprotective for cells, for neurons, and it's shown remarkable results preclinically in models of Parkinson's. And we've had some clinical trials looking at GDNF, and there is currently a GDNF in gene therapy clinical trial ongoing in the US and in Poland. There are other examples. It's quite a broad area, gene therapy for Parkinson's. But I would suggest it's still experimental.
Thank you, Simon. Question from Randy, who is basically asking if you have any thoughts on the BioV study results released in December for AD and PD.
They're very interesting. I haven't really had a chance to look deep at the data, but they had a positive effect, and that's very encouraging. I'm reluctant to say much more than that.
Understood. So a question from Lisa: do you have any opinion on or on any research, if there was past or current, related the effect of sulforaphan on PD, which is, I think, the broccoli, if I'm right?
Oh yeah. So
we spoke about that in the past.
Yeah. It is. So I'm struggling with words here, because I'm really interested in this idea, but I'm guarded in what I say, because I'm aware that there are a lot of researchers that are concerned. It involves a biological pathway called NRF2. And NRF2 can be a little bit of a double-edged sword. If you push it, if you have too little, it's bad. If you have too much, it's bad. It's sort of, it has to be a Goldilocks level of activity. And yeah, it's an intriguing area. Sulforaphanes play on this NRF2 pathway. And it's an intriguing area. It's an area that the community is very interested in, but we need more research on it. And I know people hate it when we say we need to see more research on it, but we do need to see more research on it, particularly around the broccoli approach. I've suggested in-house that we have a broccoli clinical trial, but there are people on the team here who have traumatic childhood memories of broccoli, typically overboiled variety of broccoli, and the thought of asking people to consume 3 or 4 pounds of overboiled of broccoli a day when they had traumatic memories from childhood, it's going to be a challenging clinical trial to run. But yeah, if we can get a bit more research into sulforaphanes, it'll be really interesting, because, as I say, it is interesting biology, but it's just there's a Goldilocks element to it, which we need to be careful with.
Good. In the same direction, at least for one part of the question, we have a question from Stephen, who is basically saying, thanks, Simon. Wow, impressed by your research and impressed by the amazing research taking place He's asking if there is any update on doxycycline and high-dose thiamine related to disease suppression. He's talking about like suppression, not just modification.
Okay, firstly, it's not my research, it's other people doing all this research. I'm just the silly face and the silly talking head that's discussing it. Firstly, doxycycline, there's a clinical trial in Bangladesh kicking off. We don't have many clinical trials in Bangladesh, but there's a clinical trial in Bangladesh for people with Parkinson's, looking at doxycycline and whether it can have a beneficial effect in PD. For those who are unfamiliar, doxycycline is typically used for malaria, and it's an antimicrobial. But what researchers have found is that they have quite powerful effects on reducing the aggregation of this protein called alpha-synuclein. The problem with doxycycline is that people have been reluctant with regards to having too many clinical trials of it, because if you are going in and you're killing off microbes in the gut, for example, there is the possibility that you will have some bad microbial factors that build resistance to doxycycline. And that would be bad because doxycycline is one of the few drugs that we have against the microbial world, protecting us against it. The chances of that, I can't really comment, but it is something to be cautious about. And then with high dose vitamin B1, this was work coming out of Italy, and the initial results were very encouraging, but there were small studies, and they weren't very well controlled studies, and that everybody was basically on the treatment. There wasn't placebo arms, and as a result, a lot of the research community view it as anecdotal almost, which is a shame, because if there is a beneficial effect, it would be great to know. The worry with vitamin B1 is its access to the brain. It doesn't get into the brain. It doesn't matter how much you put into the body. It's a very slow process getting it into the brain. So I'm not sure that there's a cumulative effect. Increasing the dose doesn't necessarily increase the amount getting into the brain. There's another version of vitamin B1 called benfotiamine, and that gets into the brain better. And there's been some clinical trials of that in people with Alzheimer's, and that shows beneficial effects. So what we really need to see is clinical trial of either vitamin B1 or benfotiamine in Parkinson's to actually be able to comment on whether it's beneficial or not. At the present, we just simply don't have data. That's a very long-winded answer, sorry.
I think it's an interesting answer. And actually, for anyone interested to read more about this, Simon, you published a very balanced paper, I found, about high-dose vitamin B1, B for Bravo, let's just be careful, on the Science of Parkinson's website. I would recommend people wanting to know more about it to not only look at the videos on our YouTube channel, where we have Daphne Ryan talking about it quite enthusiastically, but also looking at Simon's paper, which is very balanced, and basically you have extracted the essence of it, but there is more information, of course, in that document for those interested. I have a question here from Gabriela. It's a very interesting question, I find. Gabriela is asking if there is any research that connects mindfulness and Parkinson's.
That's a really interesting question. It's out of my area of expertise, is what I'll suggest. I do know that there is a bit of research published on this topic, and somebody's just walked through the office. I thought I was all by myself. I was mindful of the fact that I was by myself, but somebody's just walked through and I don't know this person. There is research on this area, and it's safe to say that generally reducing levels of stress and anxiety in our lives has beneficial effects on our health. Exactly how much beneficial effects it has in Parkinson's, I can't say, but I'm very mindful of the fact that I need to be more mindful, let's put it that way.
Question from Mariette. She's basically saying that PWPs with more than one comorbidities will not be the first on the list to participate in clinical trials. And she basically, I don't know if that is true, but actually she's basically saying, what does it mean for finding correlations between PD and other diseases if you're excluding people who have other serious diseases from the trial pool?
Yeah, it is a complicating factor. A lot of the clinical trials are trying to be more specific, and there's increasingly lots of exclusionaries. For example, with regards to some of the GLP-1 agonists, some of the trials are quite adamant that they don't want anybody who is diabetic. And diabetes is quite often a comorbidity with Parkinson's. If you have diabetes, you are at a higher risk of developing Parkinson's than someone without diabetes. And if you have Parkinson's and diabetes, you typically have a faster progression. That's not with everybody, but it is. There is research to suggest this. So yeah, in an effort to be more specific in the testing of a lot of these experimental treatments, there is increasing awareness of comorbidities and exclusion of individuals with those comorbidities. But you're sort of trying to do one thing at the behest of another thing. It's not with every trial though, and quite a lot of people always ask with regards to DBS, can I be involved in the clinical trial? And there are a lot of clinical trials for which DBS is not an exclusionary. So it depends on each trial.
Thank you, Simon. An anonymous attendee here complimenting you for an excellent talk as always.
Thank you.
He's basically asking whether researchers are in general looking more at increasing the quality of life of Parkinson's patients rather than curing Parkinson's. Is it the case, and what are your views on this? Do you think that researchers are focusing too much on symptom management rather than disease modification?
I think everybody's focused on improving the quality of life for people with Parkinson's, and we quite often get tied up in this argument of whether a treatment is disease modifying or symptomatic, and whether it's having a beneficial effect, whether it's having a symptomatic effect and a disease modifying effect, it doesn't really matter as long as it's improving life for people with Parkinson's. I think research efforts should be focused on it. I think a lot of researchers are typically focused on the question that's being the scientific question that's being asked, and there's a slight disconnect there with regards to what the patient community wants. But yeah, with our linked clinical trials program here at Cure Parkinson's, we've primarily focused on disease modification, but quite often we have drugs that come along that have a symptomatic effect, and we don't exclude them necessarily just because they have a symptomatic effect. We're more interested in whether they could potentially be having a disease-modifying effect as well.
And I'm sure that there are some situations like stem cell therapy where you basically are providing a solution that could last 40 to 50 years, if I remember. So it is not really curing you forever, but it's curing you for so long, or at least managing your symptoms for so long that actually that's enough.
Yeah, if somebody feels better, I don't think we should stop doing research on it.
So a question from Stephen, by the way. Hello, Stephen. Sorry, we can't talk to our audience, but I know Stephen well. I'm happy to see him joining us this week again. Stephen has mentioned vitamins B1 before that, but he's asking about Mannitol and basically whether following some work on fruit flies in Israel, was there anything positive coming out of it? I remember your paper on this, but actually, if you don't mind just sharing your opinions, that would be great.
Yeah, so Mannitol, a group of Israeli scientists found that Mannitol was having a potent effect on this protein called alpha-synuclein, and it displayed neuroprotective effects in models of Parkinson's, and they were trying to set up a clinical trial, but the resources simply weren't available for it because mannitol is just simply a sweetener that's widely available. So they took a slightly different approach, and they set up a public database, and people could take mannitol, and it was called CliniCrowd, and they could take mannitol and they could report the effect that it had on their Parkinson's. So this is sort of patient-initiated science, which is wonderful to see. And then they, based on the results that they were seeing from this public resource, they were able to encourage some funding and some researchers to do a clinical trial, but it was a phase 1 study that primarily was just looking at different doses and the safety of the trial of the molecule, and they published the results of that. But one of the concerns was that they weren't sure about how much mannitol was actually getting into the body and getting into the brain. It's a bit like the Enturin agent, where it doesn't really get into the body very well. It's not very bioavailable. In medicine, it's used to assess whether the gut is actually leaky or not, because if your gut's leaky, it'll get into your blood system. So I'm not entirely sure what's now happening with that program of research. I know that the Israeli scientists who firstly published the initial results have looked at different versions of mannitol, finding better and better molecules with regards to alpha-synuclein, but I'm not sure whether there's better bioavailability with those molecules. And yeah, it'd be interesting to follow that up. It's been 12 months, I think, since I last looked at it.
I haven't heard much about it since then.
Yeah.
So there is a question here from a gentleman whose initial is M, or a lady whose initial is M, asking an interesting question. I'm just trying to interpret it correctly, whether it makes a difference for the patients, for the symptoms progression of PD, whether the patient is aware that he or she has PD or not, because obviously many people have had PD for several years before they were diagnosed, and sometimes substantial periods of time. Has there been any research that would have been looking at whether the patient being aware of his or her condition was making a difference in the symptoms and the progression?
This is a really interesting concept. Wow, that's a really interesting idea. There's a bit of research, not necessarily on Parkinson's, but in terms of genetics, people being told that I'm not sure how they get these studies past the ethics committees, but they get told that they've got this genetic variant that makes them have some sort of output, and they look at this. They look at the psychology of knowing that detail. Yeah, I'm not aware of any research that's looked at this in terms of Parkinson's, but I'm trying to remember the name. There's placebo, there's nocebo, and it's like gene-cebo or genocebo or something that they came up with a phrase for. And because there is a concern with a lot of the genetic testing that if you're not getting genetic counseling, as you find out about your core being, that you might be told something that you don't want to be told. If you are an ApoE4 carrier, for example, that means that you have you've got an elevated risk of having dementia later in life. Do you really want to know that? And if you do know that, is it going to make you more aware and make you progress towards that end, even though you might not be progressing towards that end? It's a really interesting psychological area of psychological research, but I'm not aware of anything in Parkinson's, I'm afraid.
Thank you, Simon. Moving on to a totally different topic, photobiomodulation. Now, it's slightly controversial. Some people are passionate about it. I've seen research that was supportive of it. I've seen research that was telling us it doesn't work. Opening the closet, I've been using it myself. But I'm just curious to know whether you have a view on has there been some significant research into red light therapy that you have seen recently?
Yeah, so there has been, and I can't I'm sitting here struggling to remember the results of it. There is a number of clinical trials going on around the world. The one I'm thinking of is the Tasmanian research group. Well, there's a group of people with Parkinson's in Tasmania, and they got onto the red light bucket idea. And they were so encouraged by it that they got researchers in Sydney, Professor Simon Lewis and colleagues, to actually conduct a clinical trial, and that's ongoing at the moment. So it'd be interesting to see. Well, it's probably finished by now, so it'd be interesting to see what results they found. My attitude with a lot of this stuff is that if it's working for you, then keep doing it. The issue there, of course, is that there can be some charlatans out there who are selling snake oil. So just be careful who you listen to and who you trust before trying these things, I suppose. But there are clinical trials ongoing looking at this, and there was a biotech company, I can't remember the name of them now, but they had some interesting results. I can't remember off the top of my head, I'm afraid.
No worries. So anyone interested to know more about red light therapy or photobiomodulation, we have 2 videos, interviews of Catherine Hamilton, who is producing the Coronet. She's based in Australia, if I remember right. So those 2 videos are on the YouTube page that you can find quite easily if you look at the chat section. I'm sorry for my voice. A question from Julie, who is basically saying that she suffers from involuntary movement of the right knees and dyskinesia. Have you seen, Simon, anything in the recent research that could provide additional solutions to people suffering from dyskinesia?
There's a lot of research focused on various treatments for dyskinesia. I'm afraid it's not an area that I have much expertise in, so I probably shouldn't comment. No worries. Just briefly, the company, the names come to me. The company I was thinking of before was Photopharmax. They had some research presented at the movement disorder meeting in Hong Kong a couple of years back. That was very interesting. It was a double-blind study of people with Parkinson's on stable dopamine medication.
Thank you very much. A question from Leticia, who is asking if you have an opinion on Perdita-Baran research using skin sebum VOC, which I don't know what stands for, to diagnose PD. I don't know if she's basically referring to the Manchester University research. I'm only guessing here. I remember Joyce, basically the lady who can smell Parkinson, helped develop some tests.
Yes.
I don't know if that's the one. Perdita-Baran, I'm not too sure whether I'm getting it right here.
Yes, that's correct. That is really, really interesting research. And what I love about this story, I think it's going to become part of medical legend in that that just the background to that story is fantastic. When Joy Milne went along, this retired nurse went along with her husband to a Parkinson support group meeting and just said to her husband, everybody smells the same as you, everyone with Parkinson's. And she asked the poor researcher that was presenting at that support group meeting, why do people with Parkinson's smell differently? And Thilo Kunath, who was the researcher that was presenting that day, sort of looked at her and thought, what on earth do you mean? And then they went away and they did an experiment. Firstly, Thilo went away and asked his colleagues and said, people with Parkinson's wouldn't smell differently, would they? And they said, well, you can smell diabetes on the breath, and animals can smell cancer in oncology departments, so why not? So they did an experiment, and lo and behold, they got 12 people with Parkinson's, with 12 people volunteered to take part in the study, 6 with Parkinson's and 6 without. And Joy Milne blindly, these people were asked to wear a t-shirt for 24 hours, exercise, sleep, everything in this t-shirt. And then they put them in bags, and Joy Milne was asked to smell each bag, and she got 6 out of 6 for the people with Parkinson's. and she got 5 out of 6 for the people without Parkinson's, but she was adamant that that one that she got wrong was Parkinson's, and 6 to 8 months later, that person was diagnosed with Parkinson's. So she was smelling Parkinson's before the person was even diagnosed. It's really, really exciting research. It's patient-initiated research, and I think it's going to have a really interesting impact on the field going forward. I know that the Manchester group are trying to develop a machine to help with early diagnosis, and the medical emergency dogs, the medical research dog folks, they're training dogs to smell various things, and they've trained dogs to smell Parkinson's. So I've visited their facility, and I was terrified that one of the dogs would come and sit beside me. But at one point, one of them did, and I just sort of looked at the researcher, and they said, "Don't worry, don't worry. He's just very friendly." But it's really, really interesting. But it raises a lot of ethical and moral questions. If we don't have the treatments to help at an early stage, do people really want to know that? It kind of comes back to that question we were discussing before. It's a fascinating area of science, and I get quite carried away with it all.
So anyone wanting to know more about this, actually, we have a video for everything on our YouTube channel. Thanks to people like you, Simon. But actually, we have an interview of Joy Milne that is dating back like a year or so, where she explains her journey. And if you Google the more recent development, you will see what the University of Manchester has been progressing on with her since then. Just for people asking additional questions, I just want to say we have 20 minutes left, or 18 minutes left until 9 o'clock here in London. I'm asking you perhaps to hold off from adding more questions, because we may not be able to answer them all. I know, Simon, you're very generous with your time, but I don't want to be abusing either. A question here from an anonymous attendee, an interesting question. Do you have any thoughts on PS128, the probiotic?
PS128.
So it's a stream of probiotic that has been quite publicized, in particular following research in Asia that was showing an impact, a positive impact on Parkinson's symptoms. If you're not familiar with it, it's entirely fine. I just want to then share maybe my own experience, which is that it is very difficult to get hold of, first of all, in particular in Europe. There was a French supplier that I've been using personally for a while. Now, I don't know if it made any difference, but one thing is for sure, once I became unable to get more PS128, I saw no deterioration in my symptoms. So, but again, Parkinson's is a unique experience for each of us, so it may be working on some people. It hasn't been working for me. But so PS128 is an interesting topic. I would just say the jury is probably still out. A question from Trish, who is basically asking if there is any research on the complexity of severe orthostatic hypotension and taking traditional PD drugs, for instance, Lepodov or Midodrine, if it's highly intolerable. I don't know if that question makes sense to you, Simon. Severe orthostatic hypotension and PD drugs, is there any link that you have seen in the recent research?
Well, there's people with Parkinson's are at a higher risk of developing hypertension, and some of the medications that are currently being tested are antihypertension drugs, which could potentially be dangerous, because you don't want to be lowering people with hypotension. You don't want to be lowering the blood pressure of those individuals further. So it requires careful monitoring, but this is kind of an area that's wandering into the clinical side of things, and I'm a bit reluctant to say too much.
Mm-hmm. An interesting question from Peter, who basically said that he's a trustee of Cure Parkinson. He would like to congratulate you, Simon, on presenting these trial results in such a concise and understandable way. This is indeed simply amazing how you managed to make the complexity available to all of us. He's making a point that if there were 11,000 papers that were published on the subject in 2022, do you feel that more needs to be done to collate the information contained in those papers? Are we maximizing the use of the research that is being done, do you think?
Well, firstly, Peter is a wonderful person. I have a lot of time for Peter. I have a warm place in my heart for Peter. He is an absolute gem of a man. The problem at the moment is that we have too much data being produced, and firstly, the researchers are having a hard time being able to prioritize or focus their attention on it. And secondly, and probably more importantly, we have a very poor dissemination of the research to the patient community. And that's probably where we need to focus more attention, because as we saw with COVID-19, when you have poor dissemination of medical information to the wider population, or people start to think all kinds of crazy things. But yeah, it's an issue, and simply availability of the data as well. A lot of it sits behind paywalls, as a lot of people who try to access it will be familiar with. The publishing industry wants you to pay a fee to access it, even though your taxpayer dollars have paid for the research to be done, and your taxpayer dollars have paid for the research to be published. Yeah, that's a problem that's above my pay grade. I thank Peter for it, but I'm just trying to do my bit to slow the progression of Parkinson's. The dissemination of and the availability of research is a much harder topic.
Thank you, Simon. A question from David, who basically says that the world was able to really mobilize itself to find vaccines to combat COVID-19. There was an international threat. There was a lot of resources, people and money applied to it. But does PD suffer from being a more varied disease that affects sufferers in ways that demand a complex set of investigative approaches? If so, why is it so slow to find a cure, and why is the process so lengthy?
Yeah, there's several angles here. Number one, with a pandemic virus, you have a very specific mechanism of action, and so the researchers can very quickly determine the DNA of the virus and work out where the weak points of that virus are, where they can target it with vaccines, etc. With Parkinson's, we do not know the mechanism of action, and it might be multiple pathways of mechanisms of actions involved, as we were discussing earlier. In addition, it's a very slow progressive condition. It's not as fast as something like COVID-19, which was killing people within days, if not weeks. So, and thirdly, the population affected by Parkinson's worldwide is about 10 million people. Alzheimer's is vastly more than that, and then oncology is on top, is factors of magnitude of more than that as well. But that said, there are remarkable individuals within the Parkinson's community that are certainly having a massive impact. I'm thinking here of Michael J. Fox, for example, and he is used as celebrity to bring awareness to the condition. And then you have folks like the Sergey Brin Family Foundation. They're very quietly funding a lot of Parkinson's research because Sergey has a genetic risk factor in his family. And then you've got individuals like our own Tom Isaacs, the late Tom Isaacs, who was frustrated by the lack of research being done on curing the condition, and he decided to walk the entire coastline of the UK to raise awareness and raise money, and then started the Cure Parkinson's Foundation, Cure Parkinson's Trust, to actually bring attention to this condition. So while it's easy for the research community, the medical community, to rapidly engage and provide solutions to a problem like COVID-19, there are reasons why Parkinson's is not getting the same level of attention. Yeah, you're muted. Okay.
Apologize. Thank you, Simon, for this answer. So by the way, Jo Milne is on the line tonight. She can't talk to us, but she was sending me messages, so it's a pleasure to have her. And she will be delighted to hear about.
Joy's wonderful, I should add as well. Peter's got a soft place in my heart, but Joy's in there as well. She's a darling of a woman.
So Martin is asking for about the stem cells approach, and he's asking if there is a risk that the implanted cells will take up aggregated alpha-synuclein and so die off in the short run.
So there's research looking at this, and if you take out alpha-synuclein from the cell, it slows down the whole aggregation process. So one way of getting around this problem would be to transplant cells that don't have alpha-synuclein or produce very low levels of alpha-synuclein. But what researchers have found from previous cell transplantation studies is that, yes, these cells can take up, can start to display aggregation of alpha-synuclein. In the 1980s and 90s, there were some stem cell transplant, well, not stem cell, but cell transplantation studies in Sweden and also in the US and in other areas of the world as well. But they went back and they followed these individuals over time. And when they passed away by natural causes, they took the brains and they analyzed the brains, and they found that some of the transplanted cells did actually have these Lewy bodies, these aggregated small spherical aggregations of alpha-synuclein. So the cells can take it up, but there are ways and means of avoiding that with new technology. So it's something that could be explored.
Thank you, Simon. I'm at the stage now where I may not be able to answer all questions. I'm just picking a few. An interesting question, actually, from someone anonymously asking us whether Parkinson's is an inflammation disease in your view.
There is certainly an inflammatory component to it, and there's a lot of research being conducted on inflammation in Parkinson's, even at the clinical trial level. In Cambridge here in the UK, we have the azathioprine study, azathioprine being an immunosuppressive medication. It's a bit of a sledgehammer with regards to dampening down the immune response, but if the immune system is involved, that will give you your first indication. And then there's biotech companies that are developing anti-inflammatory approaches as well. A good example here is Roche. They bought a biotech company, the big pharmaceutical company Roche. They bought a small biotech company called Inflazome, which is developing an NRLP3 inhibitor. That's a protein involved in the inflammasome, and the inflammasome is kind of an amplifier of the of inflammation. And when researchers have looked into the brains of people with Parkinson's, they see that the inflammasome is activated. So there's a lot of research looking at different approaches targeting the inflammatory response. Yeah, we'll know in the next couple of years. We'll have a better idea in the next couple of years whether to what degree inflammation is playing a role.
Thank you very much. Just a comment privately to Julia. Julia, please send an email to our NSB, no silver bullet email address, and we will give you the details by return of your email. Going back to an interesting question by Chris, a topic which we haven't really talked about ever, I think, before, Chris is a psychotherapist, and he's asking whether the use of medical hypnosis for reducing symptoms of PD had been researched. He has successfully treated a number of PD patients to stop shaking and treating IBS symptoms.
Wow, I've never looked at this. This is really interesting. Yeah, I'm sorry, Chris. I haven't. I've got no knowledge there, but I'll definitely have a look.
Excellent. I think we have a couple of topics came up for great PhD thesis on new research to be undertaken. And I think I would probably leave it there. I have missed a couple of questions, sometimes intentionally because they were very personal, if you want, or because I didn't think that Simon would be able to answer. Simply not that you wouldn't know about it, but it was almost like more medical than scientific, if you want. Maybe just the last one too for the road from Sandra. She's basically saying that do you think that the mRNA research conducted to treat COVID can be applied to finding a cure for PD?
There are aspects of it that could be, yes. But yeah, there's a very long answer to that question. I'll just keep it short with, yeah, there is a possibility. Yeah.
You will tell us more perhaps when you do the review of 2023 and 2024 next year.
Voila.
So Simon, thank you very much. I mean, as last year, this was extremely informative, and actually, I don't know how the audience feels, but I do feel cheered up by the fact that there is a lot happening. Of course, research takes a lot of time to transform into a medical cure or at least a symptomatic treatment. But there is no lack of efforts around the world, and I do find personally quite cheered up by the fact that we're not abandoned. The scientific and the medical community are working hard to find solutions. Thank you very much for that, Simon. Much appreciated. Just a last point for our audience, just to say that provisionally the next session will be on the 6th of February at 7:30 p.m. London time. We will confirm that by email, and you will get, of course, invitations. The speaker will be Dr. Matt Phillips from New Zealand, who will be talking to us about, is there any nutritional steps that you can take to slow down the progression of your condition? So thank you everyone for joining us. Thank you again, Simon, and I'm looking forward to seeing you very soon.
Thank you. Bye-bye.